generative AI. So, generative AI is an AI that is generating new content. Initially, it started with text. Now it has transformed to what everyone calls as multimodal, which is text, images, audio, video, code, so on and so forth. And Yuku important kayamanedi, it is general purpose. So it's different from classical AI and ML applications. So Mulla for the AI and ML technology, it's primarily used to like largely analyze, classify, or predict from existing data. Algorithmically, neural networks, like a lot of things were there, but they were all like expert systems. People need specialized knowledge, and the ML systems will be for a specialized reason. You can build a predictive model, but everything was specialized. You have to do it for a purpose, and you can use it for that purpose. It was not general purpose. So Mulla Fadhiya Kona Dhaimna, you can show some images and ask, oh, is this a cat or a dog? And it will tell you it's a cat with 85% of confidence, so on and so forth. So most of the use cases have again spam detection, fraud detection, recommended systems can high, but you have to build AI ML algorithms specifically for each of the use cases. So it was out of reach for common people who are not investing a lot of time and effort on AI ML. It wasn't reachable for them. So what is different in generative AI? We can first, it is massively trained pretty much on all available data on the open web. So I'm hearing some.
Palanina, yeah. Um,
Okay. Generative AI is a different kind of AI where it is capable of generating new contents using probability models. It is fully unsupervised. We just give so much of data, and it kind of learns the pattern and the structure of data. So it's able to like draw a cat, generate new contents, so on and so forth. So the primary use cases initially were largely around writing assistance, image generation, code completion. But because it kind of knows everything, uh, it is like general purpose computer. Like you had specialized mainframe computers, and after that, general purpose computer kind of simplified. I see it as a similar analogy from classic AI ML to generative AI. Okay. So classic ML or the primary use cases where it was addressing a specific question, but generative AI is like creating content. Um, in my point of view, the most simplistic way to understand LLM, which is like one specialization of foundation model, but in general, any foundation model is it is a very sophisticated next word or next output predictor. So initially, today, if you do this, I think pretty much all LLM applications are very smart. They handle this differently. But underlyingly, as a core model, when you ask the weather today is, it will try to fill up the next word. And the way it tries to do is, okay, based on all the training, it understands the pattern and it says, okay, the weather today is in the literature and everything that it's been trained on. It might be sunny with 18% probability, beautiful 15% probability, terrible 10% probability, so on and so forth. So the model tries to pick one of them. But nowadays, uh, they kind of try to get the real-time data for it, and then they pull that in, like we call that as RAG. But though they are sophistications not inside the model, not inside the core model, it's an application layer sophistication. So the model still is largely the next word prediction. So, Ataman, we just saw in the previous one, right? So it is going to predict the next word. Now, as an application builder, does the model give you any way to control what word it's going to pick? There is no precise control, but it gives some flexibility, some knob to do it, and that's called as temperature. So if you're using API, not the UI, some of the UIs might also give you this creativity dial. It's technically called as temperature. Um, so lesser the temperature, the creativity is less, which means it will give similar answers again and again. And underlyingly, Kai4 when you try to fill it, it tries to pick the highest probability word. So the weather today is the most probable word was sunny, beautiful, then it will try to pick that rather than the other one. So you can say it as low temperature, medium temperature, high temperature, and depending upon different use cases, like if you want to use it for coding, data extraction, fact retrieval, it could be like side effects of a medicine or whatsoever. Like for all of those use cases, you don't want it to be creative. It should be very close to factual, but you cannot guarantee that. So medium temperature is for different set of applications, you have to choose a right temperature. And this is the only knob that you have to control which words the model is going to pick next and respond you back. Okay. I think we picked a different example. At low temperature, it picks the high probability word, and at high temperature, it will pick other words, and that what makes us creative. For an example, if you give a prompt, write a tagline for a coffee shop with a low temperature, it's very highly probable that it will give you similar answers, but not guaranteed, like fresh coffee, great atmosphere. If you give the same prompt again, it might give you similar response. Medium temperature, if you ask the same question, it will give a different answers every time, because every time due to a lot of math probability normalization, round off, and it's picking different, given the temperature, it picks different probable words, you will get different kind of answers. When you go to high temperature, it will become like more poetic and creative content. So because it is always a pattern matching system, LLM has a very high probability of giving something that will look like right, but it's not correct. And sometimes it fabricates information with high degree of confidence. I think that's a challenge, and that's what we typically call as a hallucination problem. So why it happens is, it is a pattern prediction machine, and it does not have any memory. So it is not a typical database engine. It's not a search engine. It's not fact checker. So it is simply predicting a lot of things. And it's largely like in one form, you can consider that as a random algorithm. It has compressed the entire world knowledge into the model with those billion parameters, right? So it's another form of compression. So it cannot recall exactly what is there. It will try to pull up contents with the same meaning. So back a couple of years back, if you ask some historical things, exactly, okay, give me the famous JFA code. Instead of it saying, ask not what your country can do, it might say something else with a similar meaning. Nowadays, due to over training, it will, for most frequently asked things, it might give you right answers. But if you ask it to, like, let's say, recollect a Tirukural or something else, it won't do a good job there. So it only knows pattern. It cannot recall things, and you cannot use it for retrieving things as is. So I think in order to mitigate this, there are several techniques. You can use prompting to kind of ask the LLM to check the answer by itself. We discussed earlier, you can set a lower temperature. You can use RAG, and you can give explicitly some materials to summarize, or when you ask questions, you can give additional data for it to improve, reduce the problem. But it is very hard. As far as I know, there is no practical way to eliminate hallucination. Okay, so moving on, I think when you try to build an application on top of AI, AI, even though it is very smart in terms of like general purpose, it won't work well in all the environments. They lack a lot of context. In some way, like they might be very good when compared to a general purpose, but it's not going to work in all environments. Let's say, even though you might have trained LLM in for a medical domain, right? Like you have trained with so much of materials, even if you employ RAG, you can give all the data. If you want to know like side effects of a drug, it may not give you precisely. If you have stored a side effect of a drug somewhere in a database, you try to retrieve, that will be much more accurate than what an LLM can typically provide. So LLM out of the box, it knows a lot because it has been trained, but it cannot be compared to us specialized in systems, expert systems. So, but there are some techniques to improve its performance, right? Given your use case, what application you want to build, what need you want to address, you can initially try to use the LLM model assess and see whether it meets your need. If it doesn't meet your need, then you can go to the next level of prompting. There are several prompting techniques. One shot, chain of thoughts, chaining, you can build workflows. There are a lot of prompting techniques which will help you to provide inline data and instructions, which will help to improve the accuracy of LLM. In a lot of enterprise setup or any business setup where you want to use, it will not have enough context. The models are trained on open data. It will never have data that a business or an enterprise or you are personally, right? Like you manage your own to-dos, you manage your own budgets whatsoever. Like it doesn't know any of those. So the way to provide that context, one of the ways to provide that context is RAG, where you give all these data, create it as an embeddings, use some vector search. Depending upon queries, you can search contextually what are the relevant data, and then you can give the actual questions with relevant data to LLM, and it can help you to meet, it can answer the questions with the given context. So that is quite a big challenge. And today, in addition to RAG, a lot of agentic workflows are coming up, and it drastically improves performance because instead of you asking a complex question, if you can simplify that, but by means of creating multiple stages like a workflow, the performance drastically improves. So I think you should start simple, and depending upon your use cases, you can keep on going with bit more complexity. And there are several case studies, right? When you try to, like, there are also other options, like you can retrain the model. And I typically do not prefer doing that because by the time you spend all the money and effort to retrain the model, you get a newer model. And given the pace of innovation, commercially, it's not viable for most of the domains and industries to fine tune the model. unless um, unless the use case really demands it, and none of these framework model kind of helps you to get the desired performance. Okay, so we kind of saw what does generative AI largely technically means. When you are trying to build an application, it's quite different from a traditional applications, right? So most of the traditional applications that we build, it's largely based on structured and semi-structured data. Like you might have databases, schemas, some fixed formats. APIs would be like JSON, XML, whatsoever, right? So that's the typical model. But when it comes to AI, it's all going to be unstructured text, images, natural language, so on and so forth. So the interaction model that you can build in our application also kind of changes. So instead of typical form, buttons, menus, so on and so forth, it has to be largely based on conversational style. And because of unstructured data, and it okay, in addition to unstructured data, there is also other difference, which is like when you try to build a typical application, you kind of know what are the rules of the systems, what are the boundaries, what are the error conditions, and it's largely predictable. There are errors, exceptions, but it is still predictable. But when it comes to AI, it is probabilistic, right? And you cannot expect what the output is, and at the same time you cannot control what it's going to do, right? So when Microsoft initially launched some of that chatbot, like for the community, it didn't even take like more than 12, 16 hours to make that chatbot completely outside of what it was intended to do, right? So it's very difficult to control what LLM output is going to be. And RAGs and a lot of these techniques helps to minimize it. But a lot of care needs to be taken in application to ensure that um, it doesn't respond to some of the questions, right? And when you try to design the system, typical systems, you will think about state management. Is it going to be microservice, so on and so forth. When it comes to AI, you will be thinking a lot more in terms of context windows or memory. And the other thing is the application suddenly starts becoming like a manager who is trying to get work from AI and largely validating and taking accountability of what AI gave rather than responsible to do some things. So that's a big difference. It also kind of introduced quite a bit of complexity in terms of how do you test and debug them, right? There is no easy way to test the application. And most of the times, in order to test, you use one other LLM or you use human reviews. You try to build some evaluation metrics. So it's quite different from building a traditional application, especially in when it comes to uh, enterprise applications, medical applications, scientific applications, where accuracy is very important. So like AI applications, like we have to, when you try to build the applications, you have to embrace this ambiguity and unstructured interaction. And you have to build guardrails and some security, which is way different from how you handle that from an traditional AI applications. Okay, so I'm gonna quickly show this is one of the application that I kind of prototyped about 2.5 years ago, and my team kind of implemented 2 years back. So this is an interface where we let customers to ask to pull up a report based on a natural query. You can ask any natural queries, and it tries to build a report and lets you to view the data, tune them, so on and so forth. If you notice it, like this applications, even though when you asked a natural language question, it tries to give one natural language some simple answers, but it showed the response in terms of graphical and tabular data. Because what we felt was If we try to show all of them in textual format, at least in context of this application, it was so verbose and it was confusing to customers. So it was way easier for them to see data graphically and in tabular format than just seeing all of these in an enterprise in a textual format. So behind the scenes, how this works is like when we kind of ask the question, AWS cost by services, it kind of uses LLM to understand, okay, to answer this question, what should I do? Is this an help question that I should look at documentation, or is this a question where I have to look up a customer specific data? Right now, this application is primarily helping customers to look at their public cloud spend and how do they optimize their cost. And in an enterprise setup, the amount of data that a typical enterprise has when they use public cloud ranges from like per month, anywhere between like 100 gig to 5 petabytes of data. It's a huge amount of data. We cannot give this data to LLM and ask anything. Rather, what it tries to do is it tries to initially use LLM as a router to kind of say that, oh, for this question, should I be trying to answer the question by looking at any of the data sets, or should I look at documentation? Should I look at optimization? Like there are multiple options. So you initially use LLM as a router to identify which path it should go. And then it says, oh, now given this question, I know it is a reporting question. I need to look at data sets. It tries to say that, oh, it has like about 100 plus data sets. In order to answer this specific question, which data set I should pick. So to LLM, we kind of present all the data sets with all the descriptions, and you will ask, okay, which is the best data set that I should pick to answer this question? And your LLM will say, okay, use data set X. Now, this can be considered as a simple prompting, but when the number of data sets becomes not 100, but 500, then you cannot construct such big prompts because the LLM performance will drop. Then you go to RAG, which kind of does some search to say that, oh, I have AWS cost services. With that, from those 500 data sets, you will reduce it to 25 data sets, and then you will give those 25 data sets embeddings to LLM, and then LLM chooses, oh, AWS cost is the best data set to answer this question. Now, this is a data set. So in order to answer this question, like a data set is like, imagine it is like a big Excel with 500 columns and 5 billion rows. You can't give the exact data set to it. Rather, in this application, what we try to do is, oh, given this question, if I have to query this using SQL, give me a SQL. Now it is very efficient because I'm not giving all the data to it. And I'm not giving customers or any sensitive data to LLM. Rather, I'm giving a schema and asking the LLM to generate a SQL. Then you pick the SQL. The SQL might not be always right. It will hallucinate. So your application tries to standardize it, and then you try to execute the SQL, and then you got an output. Now you got an output, but you don't know what would be the best UI representation for it. Then you give a sample data, and then you again go back to LLM and you try to ask, should I create a bar chart? Should I create a pie chart? Should it be a stacked chart? Should this be a bubble chart? Should this be, what should be the visualization format? So we'll go back to LLM and then we'll ask, okay, tell me what should be the chart type. And then we gave only sample and anonymized data so that the customer data won't leak to LLM, but the LLM tells, oh, you can build a bar chart. Then we try to build the bar chart, and we show that to the customers, and then we build the UI to refine it further. So this is kind of what we did to build an application, and it's.
I recorded.
Yeah, and it's kind of bit different from a typical application. So this multi-stage process is what is typically called as agentic workflows, because how do you visualize is a separate agent that can deal with visualization, and how do you execute SQL? How do you do a routing? How do you do identify data sets? Each of these are different stages, which can be considered as agentic workflow. Nowadays, the router you do not have to build by yourself with the MCP servers. You don't need custom workflow for it. The LLM is capable of the MCP app standardizes how you want to do routing typically. Um, That's pretty much what I have to cover in terms of building enterprise applications. So drop all of your questions in chat. I will try to answer them. At the end, we will open up for Q&A.
Thank you so much. Now we'll pass it over to Harish, our second speaker. Thank you.
Hi, everyone. My name is Harish, Moranavavi Harish. Thank you for the opportunity. And so thank you, Mageshta, for that perfect recount of what LLMs are. I think knowing how LLMs work is really important to knowing, that this is something that is trying to guess the next word. And, starting at that basis, it's very important to understand that that's how LLMs work. So more background. So let me actually share my slides, and then I will. Sorry, I have to, looks like since it's being recorded, I have to leave the recording and restart it so that it can be shared. Give me 1 second.
No worries.
నెక్స్ట్ సీరీస్ మరి డాక్టర్ హరీష్ అవి మెడిಕಲ್ ಫೀಲ್ಡ್ ಏ ಕೊನ ಹೆಲ್ಪ್ ಫೋರಿಸೆ ಮೆಂತ ತೆನೋ ಡಿಸ್ಕಸ್ ಕೆರೆನೋ And also some questions que dijo this, please put it in the chat and please note it down. We have a QA session at the last. We'll discuss that.
Harish, I think you're muted.
Yeah, sorry, I just noticed. Okay, can everyone see this?
Yes.
Yes.
Okay, so me and Davi, so I'm gonna explain about AI in medicine, clinical reality. At Davi, I know a lot of people think that AI can replace a lot of people in medicine, and I just want to talk about how AI can be applied in medicine, how what the limitations are, the practicality. It's very easy to make certain statements. I think Jeffrey Hinton in 2014, I believe, said, in 10 years, we won't need radiologists. But it's 2025, and there are about two, job positions available for every radiology graduate because there aren't enough radiologists being produced for the amount of volume. So I want to dive in and talk about, what the limitations are and how, I see it going in the future. Okay. So just a little bit of background about me. I am a radiology resident physician. I went to medical school at Jefferson University. In terms of LLMs, so I won the Gold Merit Award at the data science in the data science and informatics part of ACR, the American College of Radiology, for the project that looked at how LLMs can help clinical imaging recommendations. So I had written a manuscript of comparing imaging recommendations in basic LLMs that are commercially available and then a context based LLM. So, in general, we see a lot about AI and radiology. Radiology seems like it's a very easy thing to be replaced because, it's just like X-ray images and CT images and MRI images. And the way it basically works in the hospital is someone, comes into the emergency department and saying, let's say they have some stroke-like symptoms, they have some weakness on their right side. So the ED physician will order a CT of the head. And so the patient gets sent to the CT machine, and the tech runs the CT, and the images are then uploaded to a central server in the hospital, and then it's sent to the reading room where the radiologists sit and we review the images as they come in. So very recently, in just a couple of weeks ago, NVIDIA CEO Jensen Huang was discussing AI's prevalence in radiology, and I thought there was an interesting quote that he said. So Huang was saying the surprising thing about the prediction that radiologists would be the first jobs to go was exactly the opposite. The trend shows that more radiologists are being hired now as a result of AI. Um, and the reason is that the goal of a radiologist is not to study the images. The goal of a radiologist is to diagnose a disease. So I think that this is, a great sentence that he said, because it kind of incorporates a lot of the limitations that go into what we think, how machine learning and AI can be applied to radiology. So, I'm going to be talking a little bit about how AI plays into radiology currently, and as I've seen it, and how I've seen it in different departments. So nowadays, there are different AI algorithms commercially available that are FDA approved that look at one certain task. So an algorithm can flag something like an intracranial hemorrhage, which is just a brain bleed, or a pulmonary embolism, which is a lung blood clot. And these algorithms can see these types of things and bring these types of studies forward in our workflow, because in our workflow on in a given at a given time we might have two CT heads, one CT chest, one X-ray of the foot, and I can only evaluate one image at a time, right? So there are certain AIs nowadays that look at these, images by themselves and they flag it and say, hey, there might be a pulmonary embolism in this CT chest. Read this first. So it brings it up to up like number one tier queue. So that's an algorithm I've seen. Then there's other background algorithms nowadays that can calculate bone density and aortic calcium on routine CTs. So this is essentially uh, looking at the vessels, for example, and if there's calcium in it, you take a basic mathematic algorithm and you take the length of the vessel and the length of the calcification and you give a score. So this AI can easily do that. No, radiologist should be sitting there measuring the calcification and, doing that math by hand. Image reconstruction is another big place where AI is doing really well. So this is basically where diagnostic quality images are basically being re-rendered from low-dose scans, enabling faster MRIs, safer CTs, because radiation is not good for the human body, and CTs use a good amount of radiation. So being able to lower the dose of radiation is always a good thing. And then MRIs are usually very slow. Making those images take a lot of compute and time. And so back in the day, it would take almost an hour for each MRI, or nowadays it's like about 30 minutes. And you can see if it's 30 minutes, a hospital only has one or two MRIs. And so you're limited to how many MRIs you can do in one day. So having algorithms that make, rendering these images faster is a great thing. Now, here are a couple issues that I see with AI in radiology specifically. So there's something called the garbage in and garbage out problem, where models are being trained on really good academic data sets that don't apply in real world scans. So like you might see, in practice, you'll come across scans that look like this, where, you can't really diagnose anything from this because of all the lines are all different. It's not a clear image. So I can't diagnose if there's a brain bleed right here. I won't be able to diagnose that. I can't see it because it's being, artificially affected by the motion. And so when you have these models that are trained on amazing data and then deployed in reality, and this is the CT head, you scan it, what do you think it's going to do? It doesn't know how to tell you that there's, motion artifact. So it might, automatically look at this bright white spot right in the middle, and it might say that there's a brain bleed in the forefront of the frontal lobe. So there's issues like that. Then there's vendor variability issues. So algorithms that were optimized for Siemens, for example, Siemens scanners might not work on GE or Philips equipment, the CT and the MRI machines, because of pixel level differences. So all hospitals don't carry the same brand of systems. And a lot of these algorithms run only on certain brands. So that's another issue. The other issue is AI also cannot adapt to, novel anomalies, bad positioning. It might just tell you, like I said, confidently that this is a brain bleed, but it would be the wrong prediction. The other issue is context blindness. So we have, computer vision that typically just looks at images in isolation. And that's what, people usually think radiology is like. You look at the images in isolation. But there's a reason why, we have to go to medical school as well. You have to know the actual background of the patient to be able to make diagnosis. So if there was a density in a lung CT, meaning a little spot in the lung, a lung image, and the AI doesn't know the patient, cannot access the chart, or cannot properly make sense of the chart, that density can be reported as a cancer or something like that, which we don't want if it can't look at the EMR, the electronic medical record, and see that this is actually a scar from a car accident, like a bone contusion from a car accident 10 years ago, then without that knowledge, you're going to be thinking, oh, might be a new cancerous growth. So you need the prior comparison and the clinical history to be able to answer these questions, because these images are black and white images, and a mass looks very similar to a scar. So because of that, that's another limitation that AI has. Um, and then workflow disruption. So this is basically talking about the issue with current AI systems in place. For example, platform fragmentation is a very important aspect that I wanted to talk about. So when we use our tool to view our images, a lot of the AI tools are not integrated into the system. So I would have to log into another application, put in my password, and then have that system run on whatever image it is, then have that give me the answer. So instead of all of that, most radiologists are probably just going to be, you know, reading the images themselves instead of clicking 15 times and logging into different things. The other thing is uh, sensitive algorithms. Alert fatigue is very real. Sensitive algorithms flag a lot of findings, and radiologists then begin to ignore them completely, which is kind of the saying, if everything is urgent, nothing is urgent. So, for example, I talked about lung clots that are being found on with using AI nowadays. The reality of these systems, we actually have one in our hospital. The reality is when it actually runs on all of our CT chests, it basically flags the entire lung, and says that, this is a lung clot, this is a clot, this is a clot. But when you look at it, it's just a continuation of a branch of, an airway. So when things like that happen, right, I can't tell when it's actually, when the algorithm is actually showing me a real uh, pulmonary embolism. So if that's the case, I'm approaching every CT chest on my own. I don't care about that algorithm that's there. And then the efficiency paradox is essentially saying that if AI helps, lower the amount of time it takes to read images, we will end up reading more studies a day because of the efficiency paradox. So the other thing is the black box regarding LLMs. So who is responsible is a huge issue. So a lot of times neural networks can't explain why they made a decision. And if we can't explain the error, we can't trust the system. And if an AI misses a cancer that a human might have caught, who's liable? Is the hospital liable? Is the physician liable? Is the vendor liable? Um, in this case, there's a lot of legal gray zone. And then bias amplification. So models trained on homogeneous populations, which means, primarily on, let's say, a white community, might underperform on underrepresented demographics. So if you run if you uh, train models in, a community in Arkansas, and then you try to deploy it in New York, it probably will not work properly because there are a lot of demographical differences, and that's going to cause some disparities in reports. So I want to talk a little bit about where I do see AI kind of helping out in different places in medicine. So, in cardiology, for example, AI can be very helpful in, for example, in EKGs, because EKGs are essentially you're looking for patterns, electric patterns, which are a representation of your heart functionality. So if there's a heart attack, we see a exaggerated line in this EKG in certain parts of the EKG that we recognize as doctors. And this can be trained, in AI, some model. And I'm sure that there's already one out there. In pathology, which is essentially looking at biopsy results. When you get a biopsy for a lesion that you don't know if it's cancerous or not, a pathologist looks at this under a microscope to see how the tissue looks. And a lot of this is actually based off of what the pathologist thinks. It's based off of what the pathologist sees. Um, And sometimes there is some variability between, different pathologists. Someone who's more conservative might say that, this is likely benign, but not, maybe not benign, and they might want them to follow up more often. Whereas, maybe a more experienced pathologist would look at it and say, "Hey, this looks like it's benign. Don't worry about it." AI can kind of reduce that observer variability. It can probably give you a consistent mathematical cell count, maybe, and pattern analysis, which could help. I've also seen preoperative planning using AI to map out anatomy. That's also very helpful. A lot of robotic systems sometimes need some mapping at first because they need to know for example, for laparoscopic procedures, you need to know where to put the laparoscope. So knowing, having some preoperative guidance with AI augmented reality would be nice. And then I would say the biggest part where AI can help is the administrative stuff. This is the low-hanging fruit in medicine where I think that AI can actually exist today. So a lot of the things, in the hospital require notes, writing notes, and so and having generative AI help with drafting clinical notes, it's already in the market now. That's something that's very helpful. A lot of family medicine doctors have so much paperwork that they're just, working so many hours just keeping up with all this administrative tasks that AI can help with. Patient interaction, that's another place where, a lot of patients tend to, call into the clinic and the office and need the doctor to, explain something. And so having LLMs can help for that as well. And so having a human in the loop is important. I think that AI provides us a lot of opportunities, but doctors at this moment still provide decisions. And so I think having a human in the loop is important for uh, many different domains, not just medicine. And so that's my presentation.
Thank you so much, Dr. Harish. You have given a great insight. Thank you very much. Let's open for the questions for both of them. And I like to say, what a great combination. Mahesh Davi Sangyasi, Kuna LLM train Kiratamani, Harish Davi Sangyasi, there is a gap and how we can fill it in medicine mani. It's a great combo. So IT people who are interested in AI can look in, medicine people who want to jump in, they also can, learn might have learned something. It's not just AI is going to take over their job. It's a great combo today. We welcome all the questions now.
Yeah. I would like to second the final one, right? Which is like Atagudi said maturity, AI maturity heavy, it is an assistant. It can help only in productivity. And I think I think it is a productivity boost is the current role that these AIs can play.
Yeah, that'll be, I think, correct statement. Productivity boost is the current, status. I think, writing emails, making PowerPoints, elamari kam uchik, it's perfect. It helps so
Yeah,
much. But for making decisions, I think we have some time.
yeah, for sure.
We have some chat questions. Mahishta, do you want to address that? Or one such question is, do you know UI friendly RAG or Agnetic AI tool to help us build custom LLM without significant technical knowledge?
So Askidaga Kavi, you need some software engineering knowledge minimally. So one of the interesting thing could be like Gemini has something like gems. Tele vegan kona dahi minedi, it speaks to Gemini LLM. You can just add like a bunch of documents. Like instead of rack, you can give all that kai documents, kai relevant material gi tikuya DD. Then you can ask the questions. It will use the data that you have given in addition to what LLM knows. LSAV, very UI friendly, no technical knowledge. There might be tools like that. Adatu Jugu prototypes the high, like Streamlit or different frameworks. Telasubi to build Karatamusai. The Nova concept of MCP servers mini avaria. So MCP servers kavi, there are standard MCP UI apps. I mean, to knowledge of MCP server gan unta devujai, but MCP servers is also like alakarte. Askidagavi enablers I haven't seen if you want to build RAG application, I haven't seen full automation. You can use AI to build application like AppSheet. Through one application heavy code in hata kono use करता है मैंने तका जुगु applications है AI application build करता कभी I think you will need some programming knowledge. I'm not aware of. There might be a lot of recent advancements. More personal gonna be, except like things like gems or ChatGPT itself gives some options where you can do. I haven't seen a lot of tools.
Thank you so much, Mahishta. Anu, you might have got the answer, I guess. Next question, Avi. Aditya Pusarasi. Are there AIs like Chat GPT but not generative? ML Therasi for data analysis purpose?
Oh, hi. Generative AI in other Jigu AI techniques, the typical ML, me mulla sange ML like classification algorithms, prediction algorithms, mulla we credit card away, fraud detection, askidaga gavi classical AI means AI ML use kelly for the year. And Jugu data analytics tools many Jugu tools savai askitama mavigin basic BI report in Musavi, they will have a specialized package for prediction, fraud detection, askidagagu. There are like a lot of no code tools. I mean data they don't extrapolate carry they. So there are a lot of tools available for that.
Okay.
Thank you, Aditya.
Thank you.
And another question is, I think it's for Dr. Harish. Nice overview of the challenges. Do clinician need to recalibrate or adjust the interpretation when reviewing the image from different equipment like Siemens or GE or Philips?
Um, Generally, no. I mean, maybe usually like when you're working at a hospital, it's usually one vendor, Siemens vendor gan hai, namely GE vendor gan hai. But even if you were to work at a different hospital per se, I don't think it would affect our view. But me kay minimum the algorithm behind a lot of these applications might not work just because of the way that some of the intricate differences of the actual infrastructure behind these different equipments. So telemi minyo.
Thank you, Harish ji. I think Chandra ji, you got your answer. I think Harish might have answered this, but I'll ask the question. Bhaskarda has asked, this means the radiologists have upgraded their role and delegated the work to AI bots. Is it the right statement?
I wish. That means I would have no work. But no, I think current radiologists, we essentially don't use AI at all. Or if there is an AI system, it's just a nuisance in the PAC system that they don't use. So as of now, no, it's nothing has changed. Only thing that's really changed, there's just more people getting scans. There's more, the baby boomer generation is getting older. More people are getting imaged, and the amount of radiologists are capped. There's only so many residency spots a year. So there's exponential volume, but no, not really any growth in the amount of radiologists there are.
Thank you, Rishi. And Bhaskar, you got to answer, I guess. But he also mentioned that there is a real life case of Aravind Eye Hospital in Madurai, where the images were read to use read retinal image so that the ophthalmologist can spend more time in treating patients. So
Yeah. Mhm. Yeah, Levi, actually, I found a article on this, a best practice AI article. And Levi, interesting and so basically any task that makes our life easier means that we have more time with patients. So Levi, anything is good. So Levi, I think they're looking specifically for diabetic retinopathy, which means essentially diabetes riado dolamavi clot hui. So I guess image they trained a model and they ran it and on actual patients and it looks like 97.5% accuracy hodras. So LV juku important because diabetic eye disease avi India mavi juku prevalent. So elamari things that are there will be really helpful. But like I said earlier, it's not what a radiologist does. A radiologist, Avi, looks at the image and goes from bottom up and has to read every single pixel and make sure that, there's nothing wrong. AI thinks right now, Avi, one narrow task. So when that's the case, for example, in a model movie on the, let's say you run a image and there is some diabetic retinopathy, but let's say there's also a mass in the side of the the algorithm would have never saw that. So it doesn't even know that it needs to talk about it.
Mahesh,
Really have at least very specific narrow.
okay, Mahesh, the last part of your voice was been cut off, but it's tungo voice down face kagamini klarni for the just last part, and that's fine. Let capture later. We have question for Mahesh da. So in the first presentation, you have provided a flow chart for how it might answer your questions regarding what cost my service. You mentioned reading from AWS service data set, writing SOL queries to gather the data. How can you ensure the AI output is hallucination free?
Okay, so the workflow was designed to avoid hallucination, right? Hallucination hobo for humanity you look at LLM to get an answer that you are directly giving to as an output. Ata ella flow ma min kai karayo menedi. Okay, ella question kolla data set use kenomeni. Ata if LLM hallucinated and gave me a data set that doesn't exist, my application would have failed. I wouldn't have returned anything to the customer. So, I mean, kai kariya, we identified the data set. We asked LLM to generate a SQL, but SQL is something that you have, it's a programming language that you have to execute on top of a data set. It's like database and query li kariye mari. So SQL is the query, right? Data set is the database. So we LLM, you smartly design the application so that LLM is not answering the question. Rather, LLM is giving you a logic and you are executing the logic. And the logic heavy hallucination and it would have resulted in a failure. It gave a wrong SQL, then it would have failed. It wouldn't have, it cannot give a wrong data because I never gave customer data to LLM. I only asked, oh, kai query me execute can I answer karadagu. That's what I got. If I'd have hallucinated, the SQL would have failed. So that is how you design application to reduce hallucination.
So
Thank you.
sorry.
Go ahead.
If
Go ahead.
Yeah, just a follow-up question. So the AI can hallucinate the SQL query itself.
Yes.
Um, how do you like train it so that the SQL queries it generates is based on the data set you're providing? Like it knows the table names and the
Yeah.
whatever. Yeah.
Yeah. So when the LLM gave us SQL as an output, we parse the SQL and we kind of understand, oh, it is asking me to query AWS service data set. I can check whether does that really exist. It is asking to use service as a column. Do I have a service column? Like I kind of validate that. If when I don't get something, then I go back to LLM saying, oh, you gave me this, but this is my schema. It's not matching. When you ask LLM to act as a critic and correct the mistakes, it tries to correct them. So you give like one or two shots, and after that we say, I cannot answer the question. Like instead of, I think the hallucination problem is you think the answer is right, but it is not right. Right. But given the controls that we built, I know whether it is right or wrong. When it is wrong, I just tell the customers that to the users that, oh, I couldn't find this. Right. So when you know what you can do, what you don't do, there is no hallucination. The hallucination is all about you think you know, but you don't know, right? That's the hallucination.
Okay, thank you.
Thank you, Nitin. I think you got your answer. Next question is also to Mageshta. For young grads and college students, are there any AI course or certification you would recommend to help within any kind of tech space, such as computer science or business and tech? This is asked anonymous, I believe.
Okay. So the prompt engineering field but I don't see in the long term that it might be stable. It is not for students, right? If you are already looking for, you are in some job, you wanna upskill, then you can look at prompt engineering. But if you are a student, you want, like by the time you graduate, I'm sure like most of what we do in prompting would have been already baked into the LLM model. So I think I have to think about it. I don't have any direct answer or courses. I can get back after doing some research on this.
No issues, Maheshta. We'll catch up with you later, and we will send the answers to the person if you find any. Then next question is also to you. It's asked by Kubendran, I guess. Any recommendation for professional without IT background to learn AI application to their respective field?
Okay. I think it's similar to the other. So, as a concept, kalalula menedi, I think there are a lot of free courses from all the cloud providers. Like everyone tries to sell their AI model, so they kind of give some courses that will help to understand as an outsider what it is and how to use it. So, I think what my general recommendation would be, see, given the current landscape, the model is going towards general purpose. So it will know general things, but it won't know an expert domain. I think in future, I kind of think that they will start forking the model and will start doing specialized training for, like, they kind of do it already for protein discovery, synthetic biology. They specialize models, right? It's not a generic model. So it might come, I don't know. It might come in future. So knowing a domain is more valuable, and getting to know about, like, whatever is related to domain, you try to use it in using some standard AI tools might help in the long run.
Thanks, Mageshta. And yeah, I agree with that. Specific field mani on the AI high, mani on the AI Keraran, create Keraran, you have to contact that and see how it works, and you have to learn accordingly. Next question is to Dr. Harish. It's by Nagesh. Saw here at UW Hospital, doctors are using with the consent of patient using AI apps during conversation with patient. How does you see that? To Dr.
Yeah.
Harish.
Yeah, Levy, I think a lot of the scribe apps that generate notes are based off of this, which essentially, so basically on the appointment data, Levy, you have to write a SOAP note, which is basically a note that you send to insurance and you get billed based off of that. So tala likata vi it's pretty mundane most of the times. It's like, you have to write about the patient history. You have to write about the physical examination, the plan, if you're giving any, procedures, antibiotics, any medications, whatever. Tala pura likna ho riya. So most of the times, like, this is pretty very routine things that most doctors do, and it's just busy work sometimes because you have to go back and sit down at your computer and then also type this up. And so it's easy to have now these apps that generate the report based off of that. So but for that, because it's listening, you have to get patient consent. So the Lahalis, they're doing these consents.
I 100% agree. This is an administrative job doctors are doing, and AI can help out in this way. I think that's what it is. Okay, next question is by Vishwajit. I think I might have missed this, but from a medical context, do you believe that the integration of AI in aspects such as transcribing patient files, charting, or administrative tasks carries patient confidential breach risk?
Yeah, the levy, I didn't even begin to talk about that because that's a whole other issue with implementing anything AI related in medicine, because a lot of the times at AI, it's based off of, some API, and you have to, setting up everything locally is very expensive. A lot of hospital systems might not be able to afford it, except the big ones. And then the other issue is, even if you can afford it, um, there's no way right now for you to get paid by insurance companies for using AI. So because of that, there's no cost incentive to putting any of these things in. Um, but that being said, everything should be run locally in order to avoid any confidentiality breaches. But again, that comes with its own increased expenditure.
Thank you very much, Magesh. And Vishwajit, I think you got your answer. The next question is for Mageshta. Sorry, I think I mispronounced the name to Harish to Magesh. 1 minute. Let me see. Next question is for to Magesh. The question is like, because you're developing your AI, how are you trying to do any environmental friendly steps to avoid environmental effects?
Okay, so I think it's a big challenge. Okay, today, right? Cone actual AI model build career, there are only very less than like the fingers in hand, right? There are only about 7 players who can do it. right? It's a $1 trillion investment to build, like not, it's a very capital intensive task to build these models. And LIV, it requires a lot of compute, and because then it needs a lot of data centers, cooling, so on and so forth. And there is no good solution today. I think a lot of vendors are trying different things to address this, right? I think today, one of the big challenge in terms of training AI model is there is not enough power available in US to build data centers. Like they are forced to go to some other countries to build data centers because there is not enough power generation capacity within US. But on the other side, with whatever we have already created, there are already environmental impacts, right? So some of the solutions that are being tried out is like, okay, ocean bhitere within a data center build karta sariya, so that you don't have to spend time, don't have to spend power to cool things down. And I think Google recently is exploring doing things like building the data centers in space, because space are always cold. It doesn't have you don't have to spend any power for it, and it can be purely solar based. So Telamadri Jugu experiments are going. And I think on the other side, there are some bottlenecks primarily related to network speed and quantum computing. Jugu research Shalariyasi, but I don't think there is any good solution today that we can adopt.
So, young people for listening, thank you, Maheshji. You have given a good answer. So, young people there, you can find a solution for this. You guys always think outside the box. And anybody else have questions? Please raise the hand or put it in the chat. We have few more minutes to go, or we can. Anyone?
Yeah, I have something. Now Ram from New Jersey. We were late in January, so I don't know whether Magesh, you have covered any agents, AI agents or agentic AI. I think me, every can I say the like metrics, accuracy, and all those things. I think AI using agentic AI, a lot of these problems can be solved, right? For example, medical field of the problems, like transcription problems, all those things. So I think we can talk more about this sometimes in the future.
So, I mean, probably this is also a question to Harish in one way, right? I have quite a bit of some friends and my nephew who are working in India, and a lot of startups who are working in medical domain, right? So there are some things, right? Like agentic workflow can help you to reduce hallucination and other things, but I think the big challenge is there is not enough public data to train model on these medical segments. Most of the times, we can data sensitivity set. But I think a lot of startups in India, they do not have a lot of constraints. And I think the other side is also a challenge, right? Like people who have access to good medical facilities, they are in one segment versus other segment where, like, even for a simple medical shop, they are in very rural place with no accessibility. For them, is something better than nothing is also a question, right? So I think it's a lot of startups in India. A couple of my friends are working, like they try to they partner with like they are partnering with Manipal University, all the hospitals associated to it. They try to get their records, they try to train. And I think you take one general LLM and then you fine tune it based on these data, then it starts becoming better. I think they do a lot of things to anonymize the data so that it is not relevant to a customer, but they try to diversify. I think there are some challenges that are not fully resolved yet. And then
fine tune the model, right? So you don't need to use large language model. Small language models could be helpful. If, for example, Harish Madri, like transcription to just like administrative work. It may not be very accurate today, but
Yeah.
to me, agentic AI you can actually make it very, very accurate. That's what I meant.
Okay.
That's
So it depends on where you want to apply, right? You cannot apply for decision making. You can apply in other places, right?
yeah, tell us.
So most of the times, so the application kai karan minedi, you gave some notes or bulletins, you created a transcript, and these applications to be safe, given the domain, they give you the transcript, but they also pin that with the other notes that you gave, so that like it always needs a manager to validate with
Oh,
given.
tell to a human in the loop.
Yeah.
You put a human in the loop, right? Like for example, Harish can make it approve or reject
Yep. Yep.
as a approval manager or somebody like that.
Yeah. Yeah.
We can talk. That's a very powerful topic.
Mm. Mm. Yeah. Yeah.
Thanks, Ramda. Thanks, Mageshi. And Mageshi, you have another question? Aditya, you can unmute and ask the question.
Hello. This is a question about hallucinations.
Sure. Go on.
Yeah. So, if a model hallucinates, if you ask it again for evidence or where it got the info from, wouldn't it recognize its mistake?
So there are LAV. It is one of the prompting technique to improve the performance and reduce hallucination. But recently, I think Anthropic released a couple of papers, and they call kind of LLM circuit from Google. Like they kind of see now when you ask something, the model gives output, and there is very less visibility in terms of what the model actually did. So what Anthropic and other researchers they try to do is they try to borrow everything that is studied in terms of neuroscience, because that is largely studied. Neurons, connectivity, like you can think connecting neurons, how thick is it, how thin is what a medical field says. If you just put it in terms of analogy, oh, that's like between a word to next word, what is the probability? Higher probability is thick, smaller probability is thin. So they try to apply these concepts and they try to visualize it. So what they are noticing today is when you try to ask the things again, the model is kind of knowing that it is getting validated. So it tries to make some decisions, and there are a lot of edge cases where it definitely helps, but it doesn't eliminate them. It reduces, but doesn't eliminate them. That is the current state.
My follow-up was, if you, like I said, if you ask the AI to reconfirm, couldn't you automate that to is that how models are more accurate? I'm not.
It depends on the type of question that you are asking, right? I heard this recently from one of a volunteer who was teaching in Tamil school. They wanted to create some exercise, and they wanted to generate like some 10 Tirukurals, which will be easy for the kid to say. So you ask AI to generate, to give me 10 Tirukurals. You ask how many ever times to check it. It has never stored Tirukural, right? It only knows the pattern. It can never correct it, right? It cannot give. So in a lot of times it will help, but you can never, at this stage, you cannot eliminate. But like if you have used, oh, I'm giving Tirukural the entire book as a rag, and then you are asking it, the failure chance probability drastically reduces, but it still does, it doesn't goes to zero. There is still some probability for failure.
Okay, thank you.
Thank you so much, Mahesh ji. Thank you so much, Harish ji. Both of them did a great job. A lot of follow-up question. Great session. Um, I appreciate all the participants and the questions came in. Thank you very much. Any final wrap-up notes? Anybody?
Yeah, मी प्रीता वतगरत secretary.
Please.
Mage super gan hoda si mage si and Haris ji di tanga session aina unda eye-opening and hodas on the young adults, pillar and youth, I think this is one of the highest attendance session in our speaker series in the last 12 months. Bhargaviji chokod hadasi super kant me coordinate me kerasi, it was very good. And we can do one more session is also because I have seen more interest in this session. So we can continue in the next year also. Thank you, Maheshji and Harishji, both of them.
Thanks to all the organizers.
Yeah, chokot sangas to mitula ye tholi pros and cons kona whatever is that. Finally, the result we have decision hadata mean kona la use kalamandi is chokot the session. It was one of the hittest session mi sangoya mi speaker series.
We have the highest attendees for the
Yeah,
speaker
exactly.
series, this one. Dr. Harish and Mahesh, you both did an excellent job. Thank you so much. We can have a follow-up session if you guys are interested in. And we will see the, I mean, we interest savesi, and I'll survey that duesi. But this is an awesome session. Thank you, everybody.
Thank you.
Thank you so much.